Welcome back to the Future Strong podcast. We're diving into some pretty mind-blowing stuff today, all from NVIDIA's GTC 2025 keynote.
Yeah, there's a lot to unpack.
And our mission today is to, well, unpack it all, see what these NVIDIA developments could mean, for the future of AI and tech in general.
Right.
So we've got info on new AI models, brand new computer architectures, and a completely different way of thinking about AI infrastructure.
Yeah, it's a lot.
It is a lot, but let's jump right in, huh?
Yeah, let's do it.
Okay, so AI-powered reasoning models are now so much better than those traditional large language models. They're managing something like 8,600 plus tokens for really complex tasks.
Yeah.
And that's compared to just 439 in the basic models. So what does that huge increase, what does that tell us about the problems AI can solve now?
Well, I think what's really amazing is that jump in scale.
Right.
Going from hundreds to thousands of tokens. That's a fundamental change in how complex the things AI can handle now are. Think about something like medical diagnosis.
Okay.
So instead of just looking at patterns and images, and AI with this kind of reasoning power,
Right.
it could look at a patient's, their whole medical history,
Wow.
lab results, even genetic information to give like a way more accurate and comprehensive diagnosis. That's something older models could never do.
That's a huge leap. Yeah. And NVIDIA, they're also building these, I guess they're calling them digital twins of AI factories.
Yeah, digital twins.
To simulate entire data centers, like before they're even built.
Yeah.
So can you sort of explain what's the point of that and what are the benefits for us? What does that mean for us?
So really it's about optimization and mitigating risk.
Okay.
Right? By making this virtual copy, engineers, they can test different layouts, find potential like bottlenecks maybe in the data flow or energy consumption, and really fine-tune everything in that virtual world before they spend a ton of money,
Right.
building the real thing. It just makes building this huge AI infrastructure way more efficient.
Yeah.
Way more cost-effective. It's like running a full simulation of a factory before you even start digging,
That makes a lot of sense, yeah. Now, the keynote also talked about something else, humanoid robots, and how they're becoming a major industry powered by these AI models trained using, well, they've got a few things, Omniverse, Cosmos, and reinforcement learning. What does that mean for different industries, for us, for our daily lives? What are the implications there?
Well, if you think about it, we have AI with this increased reasoning power, right?
Right.
And then you combine that with sophisticated training in these really realistic virtual environments like Omniverse. I mean, the possibilities are endless.
It's hard to even imagine.
We could see a revolution in manufacturing, with robots doing really intricate assembly tasks, or in logistics, with robots managing warehouses or we're doing deliveries. And even in healthcare, right? We could see robots assisting in surgery, maybe providing care for the elderly.
That's a huge change.
It really is. And I think what's particularly exciting is the potential for these robots to work in places that are dangerous for people.
Right.
Places we can't go.
Yeah. Okay. There's also mention of, and this is interesting, an AI token and generative computing shift.
Right.
And they're saying that these tokens are they're the fundamental units, the building blocks of language and information that the AI is processing. Jensen Huang is really pushing this.
Right.
He's also talking about moving away from retrieval-based computing and more toward generative computing. So the AI, it understands, it reasons, and it just generates answers whenever they're needed instead of just, fetching data that's already stored.
Yeah.
How big of a shift is this, and what does it mean for us practically?
This is a massive shift. We're going from AI that basically just looks things up, retrieves information, to AI that truly understands and can create totally new stuff.
Wow.
And the practical side of this, I mean, it's huge. Think about personalized education, where AI tutors create custom lesson plans on the fly for each student.
That's amazing.
Or AI that can design new materials with very specific properties just like that. The token being so central, it really underlines that AI is now understanding and building solutions by processing these fundamental pieces of information.
That's incredible.
Yeah.
Okay, let's switch gears a little bit and talk about hardware. The Blackwell GPU architecture, it's officially launched, and they're calling it a massive leap forward from the Hopper architecture.
Right.
And it's smaller, and it's more energy efficient. And then there's this new inference model. It uses AI to generate 15 pixels for every one rendered pixel for path trace graphics, which is really amazing.
Yeah.
So, I mean, what kind of performance jumps, what kind of efficiency boost can we expect from all this?
The numbers are really impressive. Being able to shrink the size, reduce energy consumption, but also boost the power for AI tasks, it's a game changer.
Yeah.
And that pixel inference technology, that's going to mean much more realistic, much more immersive graphics, but using less computing power.
Right.
It means AI will not only be more powerful, it'll be more sustainable, more accessible.
That's really important.
It won't need these enormous energy footprints.
Absolutely. Absolutely. Yeah. Okay. The keynote also threw out these two terms, agentic AI and physical AI.
Yes.
So agentic AI, it's about systems that can perceive, reason, plan, take action. It's almost like AI with its own to-do list, right?
Right.
And then physical AI, it's about AI understanding the real world, things like physics, friction, and that sort of thing, which is crucial for, well, for better robots. So how do those two concepts fit together, and what kind of future possibilities do they open up for us?
I think they're really deeply connected. Agentic AI, it provides the brain power, the intelligence to think and plan. And physical AI gives that intelligence the ability to really understand and interact with the physical world around it.
Yeah.
And when you put those two together, you get these advanced robots and autonomous systems.
I see.
They can not only think, but they can function safely and efficiently in the real world with all its complexity. It's bridging the gap between that digital brain and the real world.
It's amazing to see all this come together. Now, your notes also highlight scaling AI infrastructure, talking about AI factories as, the new standard. So they're essentially replacing those traditional data centers, right?
Right.
And these Blackwell-powered AI factories, they're going to be what powers that next generation of reasoning AI.
Yeah.
Much better inference efficiency. So how will all this change the landscape of how we develop and deploy AI?
The idea of these AI factories, it really highlights this move toward the industrialization of AI development. We're not just using general purpose data centers anymore.
Right.
We're creating specialized facilities optimized for AI training and deployment. And this scaling, powered by things like Blackwell, it's going to make AI innovation happen so much faster.
Wow.
And it's going to make it possible to deploy these advanced models on a much bigger scale. It's a huge investment in the future of AI.
Yeah. And they're planning to release a new chip every single year. Generative computing is replacing retrieval computing. And AI is moving away from static models toward those dynamic reasoning-based agents. And robotics is being highlighted as the next trillion-dollar industry. So, with all that said, what's the overarching vision here? Where are we going?
The big picture. It's a future where incredibly intelligent AI is woven into every part of our lives.
Wow.
AI isn't just helping us anymore. It's reasoning, it's planning, it's acting, driving innovation in every industry. And robotics, well, robotics is going to be the key to connecting that digital world to the real world.
Right. NVIDIA is positioning themselves to be the leader in this transformation with constant advancements in both hardware and software.
It's really clear that NVIDIA's announcements, they're pointing toward a future where AI is so much more powerful, it's more efficient, and it's really integrated into our lives, both digitally and physically. These advancements in AI models, computing architecture, infrastructure, it all points to, a rapid acceleration in this field.
Absolutely.
Hopefully this has given you a better understanding of these key developments and what they could mean for all of us. So I'll leave you with this. With AI becoming so good at understanding and creating, how will our relationship with technology change? And what new opportunities will open up for human ingenuity in this new world we're heading into?
That's a good question.
Thanks for joining us on the Future Strong podcast.
Yeah, it was great to be here.